This conference will now be recorded.
Good morning to everyone. Am I audible? Good morning.
Yeah, yes.
Yeah, very good morning to everyone. So I welcome you, all of you, for this session today. So we will be begin with a Python demo session. Python demo session. So agenda of today's session will be like what is the agenda of today session will be. So we'll be talking about wh- what is a scripting technique. What is a scripting technique? So why do we need? So why scripting is required? Why scripting is required? So where we will use the scripting language? So where we will use the scripting language, and how scripting language help us to reduce the time and effort to maximize the productivity of the work. So we'll be more discussing about this productivity of the work. So this is the agenda of today's session. We will be looking forward in this session that what are the scripting language, what is the scripting language, what are the scripting languages. We'll see various scripting languages, and then why Python is preferred over other scripting languages. And if you look at in VLSI field, different domains like functional verification and digital verification field, how Python will be help us to Python scripting help us to reducing the time and effort to maximizing the productivity of the work. In same way, we'll see that what are the areas in physical design domain we are using Python script. As I said that, so this script is essentially reducing the time and effort, uh, improve the productivity of the work. We'll see in terms of design for testability, in terms of custom layout. So this will be the agenda of today's session. At the end of the session, we'll be demonstrating you one project, test bench generation for the functional verification using Python script. So we'll be more focusing on why scripting language is required. What are the scripting languages? How scripting languages are help us to reducing the time and effort. So if you see, what is a scripting language? Where do you require the scripting language? What is a scripting technique? Let us talk about what is a scripting technique. So where we'll be using the scripting technique? Why do we need a scripting technique? So if you take an example of movie, so movie script, the movie script is a short summary of how movie should be shooted. The use of the movie script is, this is nothing but a short summary of the summary of how movie should be shooted. And similarly, what is the use of this scripting in, like in terms of embedded system, in terms of VLSI field, or in terms of software IT domain? So what is the use of this scripting technique is, so this is nothing but a short way of representing what user wants, what user wants to implement. Is that you have a prototype idea, so you want to develop a script, you want to develop a programming for prototype idea, so that we'll using the scripting languages to fulfill this. Then why scripting is required? So why scripting is required is so if you look at any implementation, you want to, if you see the any requirement, that requirement can be implemented in the concise manner. So if you want to implement any script in the concise manner, so we need a scripting languages. If any requirement can be implemented in a concise manner. So in a very concise manner, so addressing the problem, any algorithm, any problem, if you want to implement in any other languages, like let us take in C language or any other languages. So basically any problem or any requirement, it requires at least 100 lines of the code to implementing other languages. So where the scripting language help us, the primary benefit of the scripting language is essentially reducing the number of lines, and also the code. If you look at the syntax and the code wise, the scripting language is an understandable language, so that essentially the one which uses to write a program for the 100 lines in scripting language, this will be reducing into the lesser number of lines. If you see, if some of the requirement, some of the, let us take algorithm or a problem is done using, let us take in C language, at least it requires at least it requires 100 lines of the code. 100 lines of the code. If the same algorithm can be implemented, like in Python or some of the scripting languages like Perl or PCL, etc., etc. This requires this implementation. This implementation requires at least 10 lines of the code. 10 lines of the code. So this scripting language can be make lot of things become easier comparing to the compiler languages. The primary benefits of the scripting languages is to making the things more easier comparing to the other languages. If you look at any job, any job, like it may be the embedded system, or it may be VLSI area, or it may be the software, IT domain. So wherever there is a repetitive task. So in these fields, if the in this area like embedded system, VLSI, and software, there is a sum of there is some amount of work, some amount of work, some amount of work is is of is of some amount of work is of automation. If you want to implement some of the work as in automation, So we need a scripting languages. So where you find this, where we find, where we find, where let us take where do we need a automation? Where do we need a automation? So where do we need a automation is if you see everywhere, wherever, let us take wherever there is a repetitive task. There is a repetitive task. Repetitive task. User needs to work on this repetitive task. User needs to work on this repetitive task. Repetitive task. So implementing this repetitive task, so we'll be requiring a scripting language. So where the how the repetitive task will be taken. So let us take the repetitive repetitive tasks. Basically, repetitive tasks are two types. Those are repetitive tasks are two types. Those are one, work that needs or that executes inside the computer, and work that needs or that executes outside the computer, outside the computer. So let us take an example for the work, the task which are doing outside the computer. Let us take if you want to filter out the size of the ground nets, ground ground net sorting machine, ground net sorting, ground net sorting machine. There is a 1 ton of, let us take, there is a 1 ton of ground ground nets. We need to filter out. We need to filter according to the size. Filter according to the size. According to the size. Size. So this is a task where you want to execute. So this is a repetitive task where we want to execute outside the computer. So in that cases, this is an automation process. So where we are user is seeing that. So for this kind of applications, we need scripting languages. If you look at the example for the work inside the computer is, let us take one example is in the front end domain, I want to generating the test benches, test bench generation inside the computer. So we need scripting languages. So these are the things where wherever you feel there is an automation process is there. For this complete automation process, so we'll be working with the scripting languages. Now let us go with what is a scripting language, what are the types of the scripting languages, and what are the essential use of the scripting languages. So why Python will be preferred over other scripting languages in each domain, in the front-end domain and the back-end domain of VLSI area. So where we'll be using the scripting languages. So let us go with the presentation. So what is a scripting language is? So scripting language is a type of programming language that is typically used to automating the repetitive task. Wherever the user requirement is a repetitive task, to addressing this kind of repetitive task, so we need a scripting language. So scripting language is a programming language that is typically used to automating the repetitive task or quickly prototype the test softwares. So these scripting languages are interpreted rather than compiled, which means that the code can be executed directly without need of any separate compilation steps. So what are the some of the popular scripting languages are like Python, JavaScript, Ruby, Perl, and PHP, etc. So these are the scripting languages. Each scripting language have its own syntax and set of features. So, but all shares the characteristics of being well suited to rapid prototyping and automation the task. So, what is the use of the scripting languages in different domain is the scripting languages uses are like the automation. It is using for rapid prototyping, using for web development, using for data analysis, using for the game development. So, so wherever I said that wherever there is a repetitive task there, to do the automation, so we'll be using the scripting languages. The automation repetitive tasks such as like file management, data processing, system administration task, and some of the rapid prototyping like quickly developing and testing the software prototypes, and then web development like the frameworks will be using the Django, Ruby, and the Rails on the which will be built on the top of the scripting languages like Python and Ruby. And for the data analysis, so data analysis and visualization tasks, so these are the powerful scripting languages to manipulating and visualizing the large data sets. And for the gaming development, many gaming development uses scripting languages like Lua to build a game logic and AI systems. So these are some of the points where the scripting languages are using. Then what are the types of scripting languages are like? If you see Python, JavaScript, Ruby, Perl, PHP, Bash, Lua, TCL. So these are the some of the I have listed a few scripting languages here. So each scripting languages is using for their specific application. So basically the Python is a general purpose scripting language, so which is widely using for data analysis, scripting, scientific computing and web development and many more applications. So this Java will be using primarily for the web development, and this Ruby will be using for web development and particularly with the Ruby on Rails with the web frameworks. This Perl is using for the system administration task. This PHP is using primarily for the web development. This bash shell is using for the bash script is using for the system administration task, and Lua is using for PowerShell scripting languages and gaming development, and TCL is using widely using for automate and the automation and scripting purpose in various industries like networking, telecommunication, aerospace, etc. So these are the scripting languages. So out of all these scripting languages, why Python is preferred in the VLSI area? Why Python is preferred over other programming languages in VLSI area is, so since Python is an open source and it is easy to learn and use, it's supporting for the large number of libraries and the tools. Over 3 lakhs of libraries are available in the Python, where if you look at other scripting languages, there is a limited supportation of the libraries comparing to the Python. And because of the flexibility, and this Python will be integrated with the other programming languages, and also there will be active community support for the Python. These are the points that why Python will be preferred over other programming languages, because its syntax simple in syntax, easy to learn, easy to use the language. It has clean and readable syntax. So basically, which makes it easier to write and understanding the complex algorithms. So it is also supporting for the large number of libraries and tools. So this Python will be having over 3 lakhs of libraries that will be computing for the scientific computing, data analysis and visualization. And also these libraries tools can be used to perform the various VLSI design tasks such as simulation analysis, design automation, and data analysis. And then it is great flexibility. So Python will be great flexibility that can be used for various tasks in the VLSI and design, from the simulation to layout generation to the verification and the testing. And also this Python will be interpreted language, which means that it does not require compilation before the execution. So that it is a more flexible and agile. So it is also integration with the other languages, like Python can be easily integrated with other programming languages such as Verilog, VHDL, C++. So it is making easy possible to create mixed language design and perform the task that requires the use of the multiple languages. And also it is a great active community support. So this Python has a large and active community of the developers and users, which provides support, tutorials, updates on the latest development in the language. This community also contributes to the development of the open source libraries and tools that can be used in VLSI design. So these are the points. So why Python is preferred over other scripting languages in the VLSI field. So if you see that how Python will be used in functional verification. So what are the points? I mean, what are the fields in the functional verification? How Python will help us to reducing the time, reducing the effort, and reducing the errors, and maximizing the productivity of the work. So one use of Python in the functional verification is nothing but generating of the test automations. So this Python script can be used to creating the automated test for the hardware and software systems. Essentially, this can save the time and increase the efficiency of the testing process. So in the hardware emulation, so Python can be used to create the hardware emulation that simulate the behavior of the complex hardware systems. So this can help for testing, debugging the hardware design. So this will be used in FPGA verification. This is also used in protocol verification. This is also used in integration testing. So also used in system level testing. So all these fields in functional verification. So we are using the Python scripting to work with in the functional verification. It's similar to this. The Python, how Python is used in physical design is the physical design to generating the layout automation, we'll be writing the Python scripts. Design rule checking, will be using the Python. Parasitic extraction, timing analysis, power analysis, and yield optimization. So we will be using the Python. In similarly, design for testability, DFT, the Python helps to do with scan chain insertion, then fault simulation, ATPG generation, boundary scan insertion, test program generation, and DFT optimization. So for this, so we'll be using, for these are the areas we'll be using the Python script. Similarly, if you look at for the custom layout, how Python will be used is for layout generation, parameterization layout, then design rule checking, then layout optimization, parasitic extraction. For these are the area where we'll be using the Python scripting. So with this, so we'll be understanding that what is a scripting languages. So basically the scripting languages are used to doing the automation. So wherever the user having a repetitive task, user feels the requirement will be having a repetitive task, to make that into the automation, so we'll be using the Python scripting. So all other scripting language will be using based upon the specific application. So why basically Python will be used in VLSI area means because of it is easy to use. The code, the syntax, if you look at the syntax is simple, and the code is understandable because this Python will be supporting for the large number of libraries. Over 3 lakhs libraries are there. And then because of flexibility and because of active community, so Python will be using in the VLSI, like in the functional verification, like in physical design, like in design for testability, like this will be used in the custom layout. So now we'll show you what are the projects we will be implementing in the Python for functional verification, digital verification, then physical design, design for testability, and the layout. So in the functional verification, these are the projects we'll be implementing for like automating the test bench generation for creating and running the test sequences for the different electronic components. So assertion based verification, then development of the verification intellectual property, coverage the driven verification, system level verification, power aware verification, then formal verification, test case development using Python, and integration of the third party tools, and forced simulation analysis, integration of different verification methodologies, development of debugging tools, and creation of the test sequences, and development of coverage matrices, and use of the machine learning and artificial techniques to optimizing the verification process to improve the efficiency of the test automation. So these are the projects. So we'll be taking up in the functional verification. And similarly, the Python will be used in uh, physical design. The projects we are taking up is for planning and placement of electronic components, and then timing analysis, power analysis, then for the signal integrity analysis, static and dynamic power optimization, then development of automated automation scripts for generating GDS2 layouts from the RTL design, then creation of automated verification script, development of routing algorithms, development of scripting debugging, and then integration of the different design and creation of the scripting for the layout analysis, and few more projects I will listed here. So these are the projects. So we'll be implementing for the physical design using Python. And also, so some of the projects we have listed here for design for the testability, DFT engineers. So these are the projects we'll be taking up. And also we'll be working on few projects on the layout, custom layout, for custom cell generation, then design rule checking, layout parametric extraction, then layout optimization, automated floor planning, and layout data analysis. And then we'll be using for Python is using for physical verification and design rule extractions. So these are the projects we will be handling for the front end as well as the back end. And then in this course, in the Python course, so we will be teaching you starting from the introduction to the Python, what is Python, what are the features of the Python, how to setting up the Python environment, then how to running a Python programming. Then, so we'll be talking about basic syntax, Python syntax. Then we'll begin with the variables and data types. So variables in Python, how to representing the variables in Python, numeric data types, string data types, Boolean data types, then type conversion. So operators like arithmetic operators, comparison operators, logical operators, bitwise operators, all the operators. Then we'll be talking about control statement like if, else, while, and then break and continue statement, exception handling. Then we'll be discussing about functions, defining functions, function parameters, default arguments, variable length arguments. Then we'll be talking about lambda parameters, data structures like list tuples, sets, and dictionaries. And we'll be talking about the file handling, then how to use the models and packages of the Python. Then we'll be talking about object-oriented programming, like class and objects, inheritance, polymorphism, encapsulation. So at the end, we will be discussing about the regular expression. So regular expressions are used to searching, matching, and replacing the pattern. So these are the syllabus we will be covering in the Python. So after covering this, the Python syllabus, we will be starting working with all the projects in the front end domain, domain, the backend domain, the functional verification backend like physical design for testability and custom layout. Now I'm going to demonstrate you how Python script is using to reducing the time, reducing the effort, reducing the error, and maximizing the productivity of the work. For showing you the demonstration, so I'm taking the example of test bench generation. So this is a program for the front-end peoples. If I want to generating a test bench where the user is providing the information, based upon the user is providing the information, so we are generating a test benches. So this is a script we have developed in the Python programming to creating the test bench if for the user is providing the information to this. So this is an example for generating the test bench. Let me run this. So this is a program I have already developed this. For this, first it is asking me to enter what is a design name. So for the design name, let me enter. I'm going to design the test benches for USB underscore controller. Now I entered the name of the design name. Now I'm going to enter how many number of interfaces I want. So we're having a front-end details. They'll be easily understanding what is the program I'm doing here. Here I'm entering what is the number of interfaces required is nothing but 5. Let me enter the number of interfaces required is 5. So now I'm going to take this interface name and number of interfaces, what are the interfaces, and what are the type of interfaces. If it is a master interface or it is a slave interface, then it's frequency, then it's a clock, and if it reset is required, or if it is required, what is the reset, and if it is not required. For this, we are generating a test bench waveform. So now here I'm entering what is the name of the duty underscore name and number of interfaces I have here. It is 5 interfaces. Now let me enter the what is the interface name. This is nothing but I2C. So I'm going to enter I2C. Then what type of interface it is asking to me. Whether the type of interface is nothing but master. I'm going to give this as a master. Now, what is a frequency? Interface frequency. The frequency of the interface is nothing but 100. So I'm going to enter the 100. Now, what is the clock? Interface clock. The interface clock is nothing but SSCL. Let me enter the SSCL. So for this test bench, I don't require the reset. So that the way I will design the program is that I don't require the reset. So that I'm going to give no. Now I have entered the interface, first interface name. Now I'm going to enter the second interface where user, in this case, user is providing the information. Based upon that information, we are converting this information into the hash of array. Then we are generating the test benches. So the second interface name is nothing but UART. The type of interface is nothing but slave interface. So I'm giving to the slave. Then the clock frequency is nothing but 200. Then I'm going to providing what is a clock name. The clock name is nothing but UART clock. And for this interface, I don't need a reset. So I'm going to give no. Then the next interface name is nothing but SPI interface. The type of SPI interface is nothing but master. I'm going to give master. And then what is the frequency of this is nothing but 200. I'll give the frequency 200. Then the clock, what is the interface clock name is nothing but S clock. I'm giving S clock. Now this interface, the no need of reset. I'm going to give no. And another interface name is nothing but AXI. Let me give AXI. The type of interface is nothing but master interface. I'll enter the master interface. Its frequency is 200. Then its clock name is nothing but AXI underscore clock. And then I need a reset. So I'll give yes. For this reset name is nothing but AXI underscore reset. Then I'll enter the last interface is nothing but ABP interface. Then type of ABP interface is nothing but slave interface. And its frequency is 10. And the interface clock name is nothing but T clock. And then this interface requires reset. I'm giving to yes. Now I'm going to enter the reset name. The reset name is nothing but P reset. Now let me enter this. Now I have provided all this information. User is providing all this information to creating a test bench generation for the DUT name USB underscore controller. So this contains 5 interfaces. What are the interfaces? Is I2C, UART, SPI, AXI, ABP, and this is a type of interface. If it is a master or a slave interface, and this is a frequency, and this is the clock interface clock name, and this is nothing but interface reset. So first 3 interfaces does not require the interface, and last 2 interfaces requires the reset. So that I've entered this reset. So this information is provided from the user. Now user is providing the information to this script. Now this script is generating the test benches. Now you can see here, this script is generating the test bench. By DUT name is nothing but USB underscore controller. Under the USB underscore controller, we are designing the design folder. Under the design folder, we are designing the RTL, and then we are designing the generating the folder using verification folder. So we'll be having it along with the top folder, we'll be having the interfaces. What are the interfaces is nothing but ABP interface, AXI interface, I2C, then SPI interface and UART interfaces. So in the top module, if you see these are the top top folder, then SIM folder, then scoreboard folder and reg folder, register folder. So we are creating all the files in the top folder. In the what are the top files we are creating is nothing but top.sv configuration file, environment file, sequence library file, test underscore library file, top underscore scoreboard sequencer sv.file. In the sim folder, so in the sim folder, we are creating run.do file, USB controller underscore list.vhe file. So if I click onto this, so these are the files we have created under each folder. In each folder in the run.do file, in the sim directory or sim folder, we are creating the run.do file. So USB underscore control underscore list.vh svh file. So like this, we have in each interface, if it is a master interfaces, these are the files we have created. If it is a slave interface, these are the files are created here. So if it is a master contains the coverage file and the driver files, and the slave interface contains the agent file, driver file, interface file, monitor file, and transaction file. So for this kind of application, so wherever user is requiring a repetitive task, so if you want to manually to do this, basically it is a time consuming. It takes more time to developing a folders like this, and then each folder creating the files. It takes more time to address this type of problems where you feel that this is a repetitive task. For the repetitive task, we are developing a script, a Python script to generating the test bench. So this is one example I took here to demonstrating that how Python script is helping to developing the test benches, where in this program user is providing the information. So like you can also pass the Excel or .csv file. From this .esv file, this data is converted into the hash of array. Using the hash of array data, so we could able to generating the test benches. So this is how the scripting languages help us to build the build any requirement, any automation requirement can be easily built using the Python script. So if you have any questions, you can kindly ask me now. Yeah, hello. I'm audible.
Yeah, yeah, you are
Is
audible.
it I'm audible?
Yes, yes.
Okay.
Yeah.
Uh, so basically, this Python will be not covering the Coco TB concept, Sai Manasa. So we'll be more focusing on any repetitive tasks are there. We'll be generating the Python script for front end and then back end. Okay, we will looking forward to come up with this Coco TB concept also in future. Yeah, if you have any doubts are there, you can ask me now.
Hello.
Yeah, Akhil, tell me Akhil.
Yeah. So, where do you actually run the code, the platform, the tools, and other stuff? Can you give some
Okay, Akhil.
description?
Yeah, okay. See, I'm working on your Google Colab. Okay, so this is a cloud-based integrated development environment. So there are so many IDEs are there for running the Python script. Like you can use Spider, Anaconda, then PyCharm, then IDE, Python IDE. Different IDEs are there. I used to prefer using Google Colab. So this is a cloud-based platform. You can integrate this with your Google Drive. So I'll demonstrate you that how to use this. If you have a Google account, so go to the Google account. So let me go to the Google account. In the Google account, I'll be going to the Drive. So, so where you can integrate this Google Colab into your Drive. So go to the new, you click onto the new. So these are some of the applications which will be using Google applications, which will be using here like Google Docs, Google Sheets, Google Slides, Google Forum. And then if you click onto the more, so since I already downloaded or installed into the My Drive, so that this Google Colab I can see here. So if you are a first time, if you go to the plus new and go to the more, you will be not seeing this Google Colab because it is not downloaded to your drive. So what you can do, you can click on to connect more applications. Go to the connect more applications. Here you can search the app from the Google Store. So here you can search Google Colab. Google Colab. Collaboratory. Google Collaboratory. Let me search. Collaboratory. If you click on to Google Collaboratory, you will be finding this one here. Now you can see since I have installed, so that it is showing me that it is already installed. In your case, you can double click this and install. So then it will be integrated to your drive. So whenever you want to use this cloud-based IDE, integrated development environment, what you can do, you can go to the new and you can easily navigate it here. Go to the more operation, there you can find the Google Colab here. So if you click onto this, so you'll be getting it the cloud-based integrated development environment. So this is coming up with the notebook with interpreter. So wherever here I can write the Python programming. Just I'm going to write the Python program here. So VLSI go. So that see here I don't need a separate separate any other like a notepad or a notebook to write my script and save and run. What I can do, I can write the script here itself. I can compile my script here itself. So this IDE basically will come up with the notepad with the integrated interpreter. So Python interpreter will be integrated with this notebook where I can write the Python programming and I can run the program here. So why I'm used to prefer this Google Colab is nothing but, so some of the Python libraries, almost 30 to 40% of Python libraries are already pip installed to this. I don't need to separately going with the pip installation. 30% of libraries already it is pip installed, so that it is easy for me to work and navigating the files and storing the files and saving these files into the drive, or you can save this into the GitHub. Many more flexible options I have in this IDE over other notebooks like Jupyter Notebook or PyCharm or any other Python open source integrated development environment.
Okay, thank you.
Yeah, did you got the point,
Yes,
Akhil?
yes.
Uh, can you explain where you have searched
Yeah,
Google
hello.
Collaborate? Yeah.
Google Collaborate, yeah, you can go to your drive, okay? Go to
Yeah.
place,
Okay.
then more operation, then click on to connect the more apps. Again, you can go to here. Search the apps,
Okay.
you can type in Google Colab. Then once you click onto this Google Colab, where you can find this.
Okay. Collaboratory team, right?
Here you have to start installing. Yeah, yeah.
Okay. Okay.
Now you
Thank
should
you.
start installing. This will this will be installed to your drive. Okay. So one more good use of this Google Colab is nothing but so it is at the server side. It is supporting for GPUs. You can change your runtime to the GPU. So you can change your accelerator to the GPU if you have huge number of data, like if you are working with machine learning and deep learning, where you want to train the more amount of data. So you can change your accelerator to the GPU and TPU. So these are the free versions which is supported by the Google. So GPU is for general processing unit and TPU is for the tensor processing unit. You can change your accelerator according to your data size so that you can learn the huge data to the machine learning algorithms or deep learning algorithms. So there are some of attractive good features are there in Google Colab. More when you started using this, you will be getting the more detail about this cloud-based IDE. Yeah, is there any questions out there? You can ask me.
In those course, will we get server access also?
Yeah, for this, to work with this, since Python is a open source, there is no need of working with any server access. You can directly go to your drive. You can start using this. So there is no separate server access to work with this Google Colab. See,
Okay.
what I mean to say, Python script run with the different IDs. Like you can use Python IDE, Jupyter Notebook, or you can use PyCharm. There's so many. If I go and list out all the Python IDs. So these are some of the Python IDs you can see here. Like ideally PyCharm, then Visual Studio Code, then Sublime Text, Atom, Jupyter, Spider, PyDev. So there's so many Python IDs are there. So you don't need to pay for anyone because since it is an open source, there
Sure.
you don't need any server access to work with all this. Yeah, this will be the 1 month training program. In this training program, 1 month we'll be starting with the basics, starting from the introduction to Python. So we'll be taking up to the advanced, up to the regular expression. So after going through these topics, the syllabus of the Python, then we'll started teaching you with if you are a front-end people, what are the projects? We will be implementing 6 or 7 projects in the front end, and then similarly we'll be implementing few projects on back end. So class time will be like we'll be starting with the 9:30 to 12:30, the timings of the class. So this will be the 1 month training program.
It will be on weekends, right?
Yeah, you can attend weekends also. There's no problem. So you can take up the course for weekdays, weekends, and e-learning also. Yeah, if you have any other questions, you can go ahead.
Here there is a theory class. So other than theory class, is there any separated dedicated lab session?
Yeah, see, we will be doing first the theory. Okay, first half of the
Okay,
session we'll be teaching you theory, and then we will
okay,
be working with the hands-on experience.
sure, sure.
So 12:30 or 9:30 to 12:30, we'll be teaching you 1.5 hour theory, and after 1.5 hour, we'll be going with the hands-on experience.
Okay.
Yeah. Yes. So e-learning videos are newly recorded videos. Yes, Sai Manasa. All the e-learning videos, whatever we have posted, these are newly recorded.
Hi, sir.
Yeah, tell me, Shruti. Yeah,
So the weekends will be like as you said before, like 9:30 to
Hmm.
12:30, right? Weekends also same time.
Yeah, weekends also same time. So it will be start at 9:30
Oh,
and end by 12:30. Yeah.
2:30. Okay. Okay, sir. Thanks.
Yes. How doubts are cleared if in case it is e-learning self-paced course? Okay, so we will be creating the individual WhatsApp group to you, Abhi, where you can post all the queries. You can post the picture with a description. So where we'll be addressing you. Okay, mentor will start addressing you for your queries. You can post all your doubts, whatever the doubts you can post in the WhatsApp group. And for e-learning the students, so we'll be arranging one session in the weekends where mentor will connecting to you, and whatever doubts are there, he will start clarifying all your doubts. Comparing to the weekend batch session to the weekdays, see, in case of weekend, it will go with 3 months. Okay, in case of weekdays, it will go with 1 month.
Weekends,
So
how
for
many
weekend,
days you
basically,
told, sir? Like,
it will take around 2 or 3 months weekend sessions.
it will be from 9:30 to some 2:30, you told, no?
12:30, yeah. So it will start in the morning 9:30 to
12:30
12:30, 3 hour session. Correct.
Timings?
Hello, Ravikran.
Weekday timings. Weekday timings.
Weekdays also it will start at 9:30 to 12:30.
Okay.
Okay. If you join for the weekend classes, if you miss the class, does we can access the e-learning videos? Yes. What are the live recorded sessions? This will be recorded. Whatever the live session we are doing, that videos will be recorded. So that will be sharing into the InSkill. So we have a separate portal. We have InSkill where we can add the path. All these recorded sessions will be adding into that path where you can find all the recorded videos. All the recorded video live sessions will be recorded. That will be shared. Yeah, if you have any other questions, you can go ahead, please.
Regarding
Okay,
the fee
regarding the
structure
fees
and
payment, yeah. Okay, regarding the fees payment, you should talk to the manager. Okay, I hope you have a manager email ID or a phone number. You can also find the details of the fees in our website also. You go through the website and find the details.
The live video sessions which will be recorded, no? For how
Hmm.
many days duration it will be available in that
Okay, you
skill
are
portal?
taking the weekend, right? Yeah. You are into the
Weekend.
weekend, right? You will be this
Yes.
course will be going for 3 months, so we'll be providing the access to 3 months. More or less, if you need 15 days or 1 month extra access, we're providing the access for up to 4 months.
Okay.
Yeah. By your request, we'll be extending 15 days to 1 month.
Okay.
Okay, if you have any doubts, you can go ahead. In case no doubts, we'll be wind up in the session here.
So the class will be, if we are a weekend student, so the class will be starting from next week, sir.
Yeah, based upon the admission and the strength, we will be deciding regarding that.
Oh, okay, okay, sure. We will
That
talk to the
anything
admin about
relating
that.
to that information. Yeah. So admin will be talking regarding that. No, when the schedule has been starting everything, so they will be sharing the mail or in the WhatsApp. Okay, regarding the start of the course.
Okay, I got it, sir. Thanks.
Hmm. Yes, obviously, Sai Manasa, will be weekend batch also will be teaching you every day. First half of the session, we'll start teaching you the theory, and then we'll go with the hands-on experience. Means lab practice sessions. Yeah. Any other questions? You can go ahead, please. Yeah. Okay. Thank you all.
Thank you.
Thank you, sir.